Okay, so question 3. The following compounds in order of decreasing pKa. Okay, so pKa, this can tell us the strength of an acid. So when you have a low pKa, then you have a stronger acid. And on the other hand, when you have a higher pKa, then you have a weaker acid. Okay, so when you have a strong acid, this means that the acid that you have can readily dissociate into its ions and kind of remain in ions in solution. But when you have a weak acid, then the acid only partially dissociates into its ions. So basically, if we look at the question, they gave us different acids, and each of them have a different number of chlorine atoms attached to them. So when you have compounds with more chlorine or electronegative atoms, they are more, or they tend to be more acidic. And this is due to something called the inductive effect. So basically, since your chlorine is more electronegative, then your protons are donated easier. So if we were to arrange the compounds in order of decreasing pKa, so let's start at high to low. The acid without any chlorines would have the highest pKa. And then this is followed by the acid that only has one chlorine atom, so Cl. And lastly, the acid with the highest pKa is the one with two chlorine atoms. Okay, so now let's see what the junior tutor said. The pKa measures the strength of the acid. The lower the pKa, the stronger the acid. Inversely, a weaker acid will have a more stable conjugate base. The order of increasing stability of conjugate base is, and then they show all the different acids when, so these when they're deprotonated, so that's what conjugate base is. Okay, so then they show the relationship, and then the chlorine atom aids in the stabilization of the conjugate base because it is more electronegative than hydrogen. Thus, it has the ability to induce electron density towards itself that results in spreading out of the electron density of the conjugate base, which we know has a stabilizing effect. The order of decreasing pKa would be the following. Yep, so it's the same order I have as well. I'm just trying to read the description. Okay, so the solution is correct. I'll just also mention the inductive effect.